We're going over question number 1 on worksheet number 4. Conservation of momentum in 2 dimensions problems. Question number 1 says a 1,000-kilogram car traveling south collides with a 1,200-kilogram car traveling east. I'm circling those not so much to remind myself of the positives and negatives, but rather when I have a south and an east, it's to remind myself that I have to do a 2-dimensional analysis here, x and y. Whenever you see south and east in the same problem, or north and west, or north and east, or south and west, or right and down, whenever you see 2 directions that are perpendicular to each other in the same problem, you must do x and y. 0 exceptions. You must do x and y. Now, sometimes it's going to be like this, where there's a south and an east. Another time it might be a south and then a north of west. 30 degrees north of west. There's a north and a west in the same problem. Do 2 dimensions, x and y. I've circled that to remind myself of that. The 2 vehicles entangle, head off as one. What's the velocity of the combined wreckage immediately after the collision? So we know we have to do x and y components here, but before we even think about x and y, we have to draw a diagram. We call a situational diagram. Not a vector diagram, that comes later. Not a free body diagram, that shows forces acting on things. This just describes the situation. This just describes what's going on in the situation. So I got a car traveling south here. It's car number 1. It has a mass of 1,000 kilograms, and it's moving at 20.0 meters per second. I've got another car going east. I'm going to call that car number 2. Its mass is 1,200 kilograms, and a velocity is 20.0 meters per second. When they collide, they stick together. Where do you think the wreckage is going to go? Like, we got a really good idea here. But even if we're wrong, it's okay. These 2 have to be drawn correctly. But if my third vector that I'm trying to solve for is drawn wrong, it's not the end of the world. It just makes it a little harder to visualize. Michael, where do you think that third vector is going to go, that combined wreckage? Yeah, somewhere south and east, right? Don't know exactly where, but... Okay, so let's do x and y components here. Let's say pi is equal to pf. Let's say m1 v1i plus m2 v2i, because there's 2 objects, equals m times vf. Good? Good? Okay, Warren, what's m1 v1i? How much of that 20 meters per second that you see right there is on the x-axis? Whenever we're doing these questions, we have to be very conscious of which axis we're dealing with. Warren, how much of that 20 is on the x-axis? 0. So we're going to cross that off, write in the 0 for it, or just leave that term out entirely. It doesn't really matter. M2 times V2I, well, we're going to say that's 1,200 times 20, right? The whole 20 is x-axis here. mass total is 2,200 times VF. We're going to solve for VF there for the x component. And when I do, it gives me a value of, I think it was 10, yeah, 10.909. Okay. Well, then I got to do the y component, right? Again, be very conscious of which component you're doing. It's important. It's critical. And don't ever try to do a question like this without breaking it up into x's and y's. Pi equals pf. We're going to say m1 v1i plus what? Dylan, what do I put in here? 0. Because object number 2, it's moving, but it's all on the x-axis. And we're dealing right now, Ed, with the y-axis. Now, like here, I wrote in the term and then crossed it off. Here, I just wrote it in 0. Some of you may just skip it altogether, which is fine. M1 is 1,000. V1I is, so what's V1I in this? How much of that 20 meters per second is y-axis? How much of this 20 is on the y-axis? Sorry? Remember how much of this 20 meters per second is on the y-axis? 20. Except we're going to make it negative because it's down. Caleb, does that make sense? Mass total is 2,200 times VF. And that gives me negative 9.0909 meters per second. Right? Now it's all physics 20. Unfortunately, physics 20 is sometimes harder to remember than physics 30 because it's so long ago. We can do this. We got 10.909 to the right. We know that because it's positive. And we have 9.09 down because it's negative. Notice this is a vector diagram. This is drawn head to tail. This one wasn't. Okay, that's just a situational. This is vector head to tail. And then our resultant vector is drawn from start to finish. Head to head, tail to tail. Where do I draw my angle? Theta. Position 1, position 2, or position 3? 1, 2, 3. Where do I draw it? Mason, where do I draw it? What? You always draw it at the start of the diagram. Hey, solve for V using the Pythagorean theorem. That works out to be 14.2 meters per second. And solve for theta using the inverse tan function of opposite over adjacent. 9 over 9.909 over 10.909 gives me 39.8 degrees. And I said south of east. If I draw a little crosshairs at the start of the diagram, I'm measuring my angle. I'm measuring my angle from the east, right? But where am I going from the east? South, right? This is south. Like, I'm going south, but I'm not measuring my angle from the south. I'm measuring it from the east. South from the east, or south of east. How many people said 39.8 degrees south of east? How many people said 50.2 degrees east of south? Equally correct, right? I'm 2 meters from this wall. I'm 8 meters from that wall. They both describe perfectly where I am, just like 39 degrees from the east or 52 degrees from the west. All right? Give you a break for 3 minutes here, and after that, we'll have you come back and continue working on questions 2 and 3 on worksheet number 4. Let's do example number 2. This one is a little different. You're going to see how it's a little bit different in a second here. This is a 3 kilogram fireworks bundle. Sits on a table, exposed into 3 pieces. First piece, 1.2 kilograms, goes north. Second piece goes 30 degrees south of east. Third piece goes, I don't know. That's what we're trying to find there. Let's first draw attention to things that can lead us to a silly mistake. Like, for instance, this whole north and south of east. We know this is going to be an XY problem, right? Because we see south and east, or even north and east in the same problem. We know it's going to be a 2-dimensional problem, X and Y. Let's draw our situational diagram and then deal with that, okay? We have this fireworks bundle exploding right here. We know that one piece goes north, 1.20 kilograms, 120 meters per second. We know that another piece goes south of east. This 30 degrees is measured from the east, but south from the east, south of east. Its value is, 1.10 kilograms. And its speed is 100 meters per second. Where do you think the third piece is going to go? It's a bit of an educated guess on this one, but where do you think it's going to go? South of west? Yeah, that seems like a pretty good guess. We don't know for sure whether it's going to go south of west or north of west. We know it's going to go west because we got an east over here. But we also have a north and a south over here. So this could go north or south depending upon which one's bigger over here. We're guessing this way. Good enough. Like these two, you got to nail these. The third one that you're trying to solve for, if you're wrong on it, it's okay. It's not the end of the world. What do you see here? What do you see that makes this a little bit different than the other questions that we've done? Questions 1 to 3 on that worksheet. Yeah. Yeah, and what do you do with the funny angle? I don't like funny angles, right? So what do we do with it? We take it over to the side, right, and get rid of it. We resolve it. So let's make this 100 meters per second. Let's make this 30 degrees. Let's make this x. And let's make this y. All you English math people who like sine, cos, and tan, which in my opinion is the best way to do this because it makes the most sense. Okay, mathematically, it works no better than the sine law, but it does give us, I think, a better understanding of vector components. Okay, for those of you who know sine, cos, and tan, which trig function would this be to find x? This is adjacent. This is hypotenuse. It's going to be, yes, so let's say cosine 30 degrees is equal to adjacent over hypotenuse. 100 cosine 30, I think, is 86.6, I want to say 602? 86.602? Is that right? And then the y component we'll find using the sine function. This one's really easy. Opposite over hypotenuse, y is equal to 50. Now, I like to, this is just my little thing, but I like to kind of box this off because this is what makes this question different than those 3 questions on worksheet number 4 that you've already been working on. Like, if you take what's inside that little box, it's different. But other than that, it's pretty much the same. So I box it off just to kind of remind me of what's the same, what's different about this question versus the last questions you're working on. Now, I don't know if you want to do this. I sometimes do, I sometimes don't. Like, when we took that 100 over to the right there, off to the side, we got rid of it because we didn't like it. We never want to see it again. That 100 is dead to us. We never want to deal with that 100 meters per second ever again. So to remind me of that, I may do this. I may choose to erase that 100 completely and replace it with an 86 and a 50. I'll keep the 1.10 kilograms in there because the mass hasn't changed, but the 100 meters per second is gone now and replaced with an 86 and a 50. Now, other than the vector that I'm trying to solve for, which doesn't really matter if that's a funny angle or not, other than that angle, I don't have any funny angles. Everything's 90 degrees. Okay, those are the easy ones, right? Relatively speaking. So let's figure this out. Let's go x components. Pi is equal to Pf. Anybody tell me what the initial momentum is? X component? Of this fireworks bundle that's sitting on a table? 86. Nope. 0. It's sitting at rest, right? We got 3 objects afterwards. M1 V1F plus M2 V2F plus M3 V3F. Man, it would be nice if those masses were all the same because they could cancel, despite the fact that there's a 0 on one side. They're not, though. What's V1F? V1F, X component here. Ed? Yep. 0. It's all on the y-axis, right? Cross that off. M2 is, what is M2? 1.1 kilograms. What's V2F? 100 meters per second, right? No, wait. 100 meters per second is dead to us. We replaced it with what for the x-axis? How you got that? 86.6. Plus M3, which M3 is 0.70 kilograms. You guys know how I got that? I mean, do you know how I got that 0.7? How did I get it? Yeah, all the masses have to add up to give me what I had before, right? Good. So we solve for V3F here, and it works out to be, for the x component, that is, negative 136.0896 meters per second. And we do our y's. Or once again, we say pi is equal to pf. Zero initial still. Three terms, because there's three objects. First time we've had to do that, I think. What's V1F this time? Sydney, what's V1F? V1F, object number one, y-axis. Remember, we have to be conscious of which axis we're dealing with. This time we're dealing with y-axis. How much of that 120 is on the y-axis? Yes. So it's 1.2 times 120. Good. M2 is 1.1. V2F. Now what's V2F? Remember, y component here. How much of that 100 is on the y-axis? We're not using 100, right? Because it's dead to us. How much of it's on the y-axis? 50. Except we're going to make it negative because it's downward, right? And 3 is still 0.70 as V3F. And for that we get negative 127. Okay. Now it's physics 20, right? Now it's physics 20. Now we just say 136 this way. 127 this way. And our resultant vector is from start to finish. Draw my angle at the start, solve for V. Pythagorean theorem. V works out to be 1.9 times 10 to the 2. And theta works out to be, it's the inverse tan function of 127 over 136. Gives me 43 degrees. What is that, south of west or west of south? I think, did you say it? South of west, yeah. All right, we're measuring it. We're measuring it from the west right here, right? From the west, but it's south. From the west. Or you could have said 47 degrees west of south would have worked as well. So look at this again. Look at this. What's different about this? This, see a funny angle. I don't like funny angles. Take it off the side, get rid of it, break it into X and Y, and then remember, never use that number again that you got rid of, never use it again. 100 meters per second, gone, dead. It's replaced with an 86 and a 50. And we know what to do there. We know what to do there. All right? We'll pick up this tomorrow. Your homework tonight is just questions 1 to 3, no additional questions. If you finish those, great. You have no homework. If you're not finished those, please finish them up as best as you can. We'll go over 1 or 2 of those tomorrow. And then we'll do a couple questions like this in class tomorrow.